Hello friends, very good morning. Welcome to Engineering Basic. Today we will study to find whether a number is prime or not, or to find or to check a number is prime or not. Okay, and if you haven't subscribed this channel, then please go and subscribe to see my further video. Now let's come to the problem to find the number is prime or not. I'll write first question. Write a program to find the whether to find whether a number is prime or not, or you can tell write a program to check a number is prime or not. Okay, now we'll see here which number is what is prime number. First, what is prime number? As we know that, and we have studied in childhood also, prime number is a number which is divisible by 1 or by itself, right? And this also we should know, the factor should be only 2. For example, we'll take for example 1. We'll take one example 3. What is the factor of 3? 1 and 3, right? This is the prime number. If we'll take example of 4, then what it will be? 1, 2 and 4. There are 3 factors, so this is not a prime number. The factor should be only 2 for prime number, right? And the remainder should be 0. And that number is known as prime number. We'll take one example. Okay, we'll take we'll take 7. For example, 7 we'll take. How to solve this? For example, 7. If I will divide by 7 divided by 1, what it will come? Remainder 0, means 7 1 is 7, it will come remainder 0. If you will do 7 divided by 2, how much it will come? 2 3 is 6, remainder 1, right? In this way only you will get 7 divided by 3. 7 divided by 3 equal to how much it will be? 3 2 is 6, 1 7 remainder. 7 divided by 4 you will do. What will come? 4. 7 divided by 4, what it will come remainder? 1, right? 1 means you will get 0.75, means 1. You will not get 0, right? In this way only you will get 7 divided by 7 equals to how much you will get? 7 1 is 7 0. There were 2, 1 and 2. There are 2 factor, means there are of 7 factor it will be 7 equals to 1 comma 7. There were only 2 factor, so these number are as a prime number. Okay, how to solve in flowchart? We'll look now this. How to solve in flowchart? We'll take one count variable, right? We'll take one count variable in this program. When when remainder will be 0, when remainder will be 0, then count will be increase. Count will be increase. Understood this thing? When count will be increased, when count will be decreased. When the remainder will be 0, then the count will be increased. Means one times remainder will be 0, then the count will be 1. If remainder will be again 0, then count will be 2. In this way only the count will be increased. Okay, now let's come to the problem how to solve in flowchart. Here we'll go on declare what we have to keep, remainder, right? Sorry, here you have to count, count, you have to count. So write count here. Then you have to take number, means any number you will divide. So I have took 7, suppose I have took 7, that is our norm, means number. And for initialization we have to take I. Understood? Now what you have to do, go near output, write a program, enter subdivision, enter any number which you want, now give input norm. What you will give? Norm, right? Now what you will do, I equal to 1, you have to initialize in for loop. I'll use now in for loop, I equal to 1, right? Then what you have to do, I have discussed in every video that in count sum what it will be 0, count equals to 0, right? Understood up to this much? Now our program will go on looping. You have to use for loop, while loop. If you use while loop, don't use I equal to 1, right? Now what you will do, what variable will be I, the starting value here it will be from 1, right? The ending value it will be norm. Okay, we have done this much. Now we have to check, we have to check here our number is it gives remainder 0 or not, right? Our number gives remainder 0 or not. Then go to take a decision, go on if norm number 7, right? Mode remainder, here is I in for loop, so we have to take I to check remainder equal to 0, right? We have to check our number is gives remainder 0 or not. If it will give 0, then what I have told, if when remainder will be 0, then the count will be increased. When remainder will be 0, then count will be increased. Go on assign, count will be increased. COUNT count equals to what will be count plus 1. It will be increased by 1, right? It will be increased by 1. Understood this? Look here first. We'll take, for example, we'll take here 7. For example, we'll take here 7, right? If here it will check 1 to norm, it here is telling 1 to 7 norm. I means 1 to 7. Here is norm means 7 remainder I. Norm is our 1. It will check from 1. Then we'll get here 1. Then again it will check here. It will come here. Count is 7 1 just 7. It will be remainder 0, right? Then it will come true side. True, it will be count equals to count 0. Here is 0 plus 1, count 1 happened. Again it will go here. Again it will calculate here. 1 finished. Here I equals to 1. Now it will check with 2. 7 remainder 2. It will be 0. Not it won't be, then leave it false. Again it will increase 3. Again 4 5 6. Again it will come from 7. 7 remainder 7 equals to 0, right? Then it will be count equals to count was 1 first. 1 plus 1 2. If count it will be 2, then our remainder, then it is a prime number, otherwise it is not a prime number. Go on. If count will be 0, 2 means factor 2 I have told that time. Then what will do? Count equal to 2. It will check. Then the number is prime, otherwise the number is not a prime. Understood? The number is prime, right? Otherwise the number is not a prime. The number is not prime. Understood? Now we look here. What we have to? We have to count norm and I. Here, what is the work of count? You got it. When remainder will be 0, then the number 0. Then that much time count will be increased by 1. Right? Number is the work of 7. If you have took 7, then that is the number. I for initialize. Yeah, in for loop you have to initialize. You have to assign here only I equal to 1. I have gone in for loop. If you will check with 7, you got it this thing. If you will take 7 more, I'll take one example of 3. Okay, I'll take one example of 3. 3 is a prime or not? The number is 3. I have to assign 1 to 3. Means number is 3. 3 more 1 equal to 0. It will be yes. 3 1 are 3. Remainder will be 0. Then count will be 0 plus 1 1. Right. Then again it will go here. Then it will take with 2. Means I is equal to 1. It will increase by 1. Means 2. It will be check 2 more 1. It will be 0. Not. Then it will go false side. Right. Then again it will go here. It will go false side this side. And then from here it will go run here again. Here it will go. Then it will check with 3. It will come here. 3 more 3. 3 more 3 more 3 equal to 0. If 3 1 are 3 means it will be remainder 0. Then it will come here. Count was 1 first, and 1 plus 1 2. Count will be 2. Then again it will go here, right? If it will be count 2, then here it will come. If it will be count 2, then the number our number will be prime. Otherwise the number will not be prime. I'll check this with 7. The number is prime. I'll check with 3. The number is prime. I'll check 4. The number will not be prime. Number is not prime. I'll check any number 5. The number is prime. Anything 63, it will be prime. Yes, 63 not prime. 72 not prime. You can check any number. 99 is also not prime. Okay, you can check any number as you want. Now understood up to this much? How to solve to check the number is prime or not? Now let's come on output. Thanks to engineering basic. Thanks to engineering basic. Now we'll check here. 89. The number is prime. Our 89 is prime, and thanks to engineering basic. And if you haven't subscribed to this engineering basic, then please go and subscribe to see all this type of in flowchart. And after this, see your lot. If you will get this logic, then you will solve C, C++ and mostly every programs. Okay, and if you haven't subscribed, then please go and subscribe to see this type of video. And thank you.